project is smart pet feeding system. Here we can see in our bottle dispenser the food is there. We have used 3 sensors in this project. There is our ultrasonic motion sensor, and here is the PIR sensor, and we have seen when I have put my hand in front of the sensors, the system has actually detected my hand. The PIR sensor have detected the motion of the sensor, and the ultrasonic sensor have detected the a living creature or the pet is actually in 30 centimeter distance from the sensor. That's why the dispenser, the servo motor, we can see here, have dispersed the food. We can see in the box that a LED red light is beeping because we can see here that an LDR sensor is mounted in the box. The LDR sensor actually indicates that the food level is below the sensor, below this sensor level. If we put food in this dispenser, my group mate Sajid Imam Mahir is currently pouring food in the box, and we can see the food have covered the LDR sensor and the light have stopped beeping in the box. We have seen that first time when I have put my hand near the sensors, the servo motor have dispersed the food. But now when I put my hands near the sensor, or my group mates are putting their hands near the sensors, it is not dispersing any food. Why? Because we have used an RTC module here. If we can see from our serial monitor that next feeding time is 22 o'clock, which means 10 o'clock at night. We have used an RTC module to monitor the time. We have actually selected 4 fixed timestamp, which is 8 a.m., 2 p.m., 7 p.m. and 10 p.m. In this time frame, if the cat comes near the sensor once in this time frame, the food dispenser will give away certain amount of food. But if the pet comes near the sensor again in this time frame more than once, the food dispenser will not disperse any food, rather it will wait for the next feeding time to come. Thank you. That's all from my side from the demonstration of our project.
Assalamu alaikum sir, ma'am. I am Sajida Mahir from section 2 group 4. The project we worked on, you saw the demonstration of the smart pet feeder. I'm going to cover the part of the ultrasonic sensor, of how we have used it. The ultrasonic sensor has 4 pins, VCC and ground, which we have taken from the breadboard, and the breadboard connections were given from the Arduino Uno. Here we can see that. And there's also 2 pins, a trick pin and an echo pin. In the code we can see the trick pin has been defined in 3 and the echo pin has been defined in pin 4. These are the digital pins of Arduino Uno. Here these connections have been given. We have used the new ping.h library, which is a fairly easy library to use with servo motors. At first, the new ping library creates an instance called sonar, which takes the trick pin and the echo pin as inputs. These sonar will be actually used to calculate the distance here, int distance unsigned, with the help of ping centimeter function. So here we don't have to actually calculate any manual data which we need. It is already given through this function. So the distance we get is then passed on to a if statement. If it is less than 30 centimeter, our servo motor will open the dispenser, as we can see in the actual project. This servo motor part will be covered by Ashikin. So I'm going to briefly say how this actually works, the ultrasonic sensor. There is a echo pin and trick pin. As we saw, trick actually directs the ultrasonic sensor to give out a ultrasonic wave, then it deflects on an object, and the echo pin actually catches that object, that this object's reflected wave, then the distance is calculated. The equation is actually distance equal to half due to the going and coming. There is two distance to be averaged, and into the velocity of sound, which is 343 meters per second, into the total time that has been taken from the time to start with the trigger and then come back to the echo. So that's for the ultrasonic sensor part. Here we can see the ultrasonic sensor was mounted here, and this is the inner portion of the ultrasonic sensor here. So I've also helped with the hardware aspects of the project, but here ultrasonic sensor is not sufficient enough because it actually detects every object, even if it's a non-living object. But we don't want one that. We want a living object or the pet to be detected. For that, PIR sensor has been used, which will be covered by Navid. That's all from me. Thank you.
Assalamu alaikum. I'm Qazi Habibullah Shikin, and I'm going to cover the RTC module part and the servo motor part from our smart pet feeder project. We can see on the screen that we have predefined 4 time frames in which the pet will be fed. We can see the first time frame is from 8 in the morning to 2 in the afternoon. In this time frame, if the pet comes near our pet feeding system, the sensors will detect that the pet is nearby and pet is nearby. There is a counter we can see in the screen that if the counter is 1, it means the pet have not been fed in this time frame. So if the counter is 1 and the pet is nearby in this time frame, our servo motor, we can see in this code that if the counter is 1, the servo motor will function. In this move servo function, we can see that servo motor will rotate 180 degrees and it will stay like that for 1 second, and it will move back to 0 degrees. We can see in this picture that the servo motor is actually holding the lid of the dispenser. If it when it is time and all the conditions are met, the servo motor will actually turn 180 degrees and thus totally opening the food dispenser, and it will stay there at 180 degrees position for 1 second, and then it will turn back to 0 degrees, thus stopping the dispersion of the food. We have used the RTC module to track the time in real time. The RTC module tracks real time and gives real time data to the microcontroller. The RTC module, in the picture we can see the RTC module have backup battery which keeps it running even if the microcontroller have lost the power. RTC module also handles lost power. We can see in this code. The RTC module will detect if it has lost any power from the last time. If it has lost full power of the module from the last time set, it will actually prompt to set the time again to the user. That's all from my part. Thank you.
Assalamu alaikum. I am Shafakat Sorar Arnab. My ID is 20101129. I am going to talk about the LDR sensor and how we have detected the food level of our smart pet feeder system. Initially, we wanted to identify the food level by using a load cell, but as it was unavailable, we tried to use the LDR sensor, and by detecting the light, we wanted to identify the food level for the smart pet feeder system of ours. LDR is a light dependent resistor. As the name states, is a special type of resistor that works on the photoconductivity principle, means that resistance changes according to the intensity of light. its resistance decreases with an increase in the intensity of light. In our code, here we have in the LED pin is set to pin 13. This is the pin where we have connected the LED, and here we defined the analog pin A0 as the pin where the LDR sensor is connected. Next, here in this code, uh, this line reads the analog input from the LDR sensor and stores the result in the variable LDR status. The analog read function returns a value between 0 to and 1023, representing the voltage level on the analog pin. In this case, it indicates the light level falling on the LDR. Here, uh, in this code, this is the key part related to the LED and the LDR interaction. The code checks the value of LDR status. If it is less than or equal to 100, it means that the light level is low or the LDR is in shadow, and it turns off the LED by setting the LED pin to low. If the light level is greater than 100, it means that there is sufficient light or the LDR is exposed to light, and it turns on the LED by setting the LED pin to high. This logic controls the LED based on the light conditions detected by the LDR sensor. And we added the delay because finally the delay of 1 second, this ensures that the LDR reading is not taken too frequently, helping to stabilize the sensor readings and avoid unnecessary processing. It can prevent rapid fluctuations in the LED state due to minor variations in the LED level or light level. Actually, the LDR sensor status is read in our system, and based on the detected light level, the code controls the LED to indicate whether the LED whether the light level is below or above a certain threshold. Actually, in the picture we can see that here it is the LDR sensor, and if the food level is high above the LDR sensor and it will be in the dark and it will not be exposed to light, then the this LED light will not be high. When the food level decreases and the LDR is exposed to light, then this LED will be high. Thank you.
Assalamu alaikum, sir and ma'am. I am Navid Alfi Hassan, and our project is automatic pet feeding system as demonstrated in the video. Now I will cover about the PIR sensor that was used in our project. We have particularly used a PIR sensor in our project since it determines the movement of living objects through the fluctuation of radiation or infrared ray. It can be seen that we have used our PIR sensor here. So if any living object comes close to it, or if any living object moves in the field of its view, then it automatically detects the radiation or fluctuation of the thermal heat and determines that a living object has come close and detects it. A PIR sensor basically has 3 pins. One is connected to the ground, one is connected to the VCC, and the third pin is connected to a digital 2 pin, which is defined here. For our project, we have set some predefined some variables such as PIR sensitivity is set to 500, which is the threshold for our sensitivity. The PIR state is primarily set to low, denoting that no living object is primarily detected. The PIR cooldown and PIR cooldown timer are used to keep the fluctuation of object detection in check. The PIR cooldown timer is primarily set to 10 seconds. Next, in the current PIR state, we have digitally read from the PIR pin, and if any living object is detected, the current PIR state will be set to high, and if any living object is not detected, the current PIR state will be set to low. And in these conditional statements, we have checked that if the current state is high and the cooldown timer is less than 10 seconds,
then the PIR state will be set to low. But if the PIR current reading is high and already 10 seconds have been passed, then the overall PIR state will be high, determining that a living object is detected by the PIR sensor. So with this PIS, if conditional, we can properly keep the fluctuations in check and precisely keep the accuracy of living objects here. For our project, we have used multiple sensors such as the PIR sensors, the servo motor, ultrasonic sensor, and LDR, but we have also tried to use the HX711 weight sensor, which we wanted to use to keep the amount or keep the accurate weight. But due to the fluctuation in load cell, we could not get the accurate weight, and we kept getting wrong and fluctuating answers. So we have removed that, and instead we have used the LDR sensor, which is already described by Arnold. So that's all from my side. Thank you.